All right, so the title of our notes, writing equations for secant and cosecant functions. And the first example, we're just going to jump right into it because we do have a background already graphing and writing equations of sine and cosine. So we're just going to apply what we have learned to some of this new material. And so the first problem here says to write the equation of a positive cosecant function with an amplitude of 6 and a period of 7. I'll give you a minute to write that down, and then we'll start talking our way through that. That work? So when you're writing an equation, and if you're stuck with any of these, one good thing is just draw a picture, because sometimes that will help you out. And so you don't have to draw the picture. If you know exactly what you're doing, you can jump right to the answer. But one good strategy, if you are stuck, is to draw what's given to you. So here I'm going to draw this. Here's my x and y axis. We have an amplitude of 6. So if the x-axis is the middle, we go up 6 from the middle and down 6 from the middle. And then we're working with the cosecant function. So I'm thinking, well, what's the reciprocal of cosecant? It's sine. And so I sketch the sine function. This is the helper function, so that's why I'm dashing it. So not the actual function. Wherever my helper function hits the x-axis, that's where I have these vertical boundary lines or vertical asymptotes. And then my actual function, where there's a maximum, I'm going to draw that happy face in between the boundary lines. Where there's a minimum, I'm going to draw the sad face in between our boundary lines. Okay. So that's what our picture looks like. They also say the period of this function is 7. So a period of a function is the full pattern, like you've gone around that unit circle one full time. And so we split this up in the quadrant 1, 2, 3, 4. We've completed our pattern, and so the 7 goes here because we started at 0. Right? We started at 0, ended up at 7. All right. So there's our picture. So what do we do? You guys have some background here. So yeah. So y equals 7 cosecant, you said? Of 2 pi? Oh. You were giving me an equation to help solve for b is what you're doing. Okay. Sorry. The 6. And then we got to find out what b is, and you were giving me an equation for that, which was what? Close. We're missing one thing in there. 7's our x value. So 7 times b, or b times 7, equals 2 pi. Exactly. And then we divide by 7, we get b is equal to 2 pi over 7. And that is what we're going to plug into our equation. So we end up with y is 6 times the cosecant. Okay. of 2 pi over 7 times x. Okay, so it's very similar, almost exactly the same process you would go through for sine and cosine, except you're using secant and cosecant. Okay, so I'm going to give us 2 more examples to just see what it's like, and then set you free to work on these problems. Okay, number 2, write the equation of a secant curve with asymptotes at x equals 1 over 6 and x equals 1 over 2 within the first period, and has a y-intercept at 0, -7. Again, I'll give you a minute to copy that down, and then let's all start with a picture on this one, okay? So after you write that down, sketch your picture. If you're still waiting, write your equation. Go ahead and try to finish it. So when writing this, we start at the y-axis. It's kind of where you want to start. And they tell us the y-intercept, so that's a good point to start at. So there's a point here at -7. And we're looking at the secant curve, and the secant and the cosine, which is the reciprocal, are going to share that point at the y-axis, because we know the cosine looks something like this, where the secant, wherever there's a maximum, the secant's going to have something going this way. So they share that point at -7. Also, our secant curve, wherever our secant curve hits the x-axis, that's where we're going to have that vertical boundary line or vertical asymptote. So we get some kind of shape like this, right? And then we're told that the asymptote is at 1/6 and 1/2. 1/6 is the smallest one, so I have one right here. So this is a 1/6, and then the 1/2 would be right here. Does that make sense with what we understand here? So if I count by 1/6, this is the first piece. Second piece would be right here, so this would be 2/6. Third piece would be here, it's just 3/6, which is 1/2. And then here's where we would end at 4/6, or 2/3. Okay. So, okay, we feel pretty comfortable. We got the right picture now, and we understand what's happening here. And then we're ready to graph. So y equals positive or negative? Negative, what number? 7, and then secant of something times x. We got to find that something. And to find that something, we're going to grab one of those numbers on the x-axis, and it really does not matter which one we grab. Which one do you guys want to grab? 1/6, the first one? Okay. So we're going to say b times 1/6 is equal to, now here's where it matters. Depending on which x value you grab, it matters what you set it equal to. So this is at the end of the first quadrant, so we got to set it equal to 5/2. And then multiply both sides by what? 6. So the left side, I get 6/6, which is 1, so I just get a b on the left side. When I multiply the right side by 6, you only multiply the numerator by 6, and you get 6π/2, which is 3π. And so, final answer on this one is y is -7 times the secant of 3π x. Okay. Last one. Last one, I'm going to give you a picture, you draw the equation. I won't tell you what it is. Okay, I'm just going to show you the picture. Be careful. Here it is. Number 3. Give me the equation of that. So, when you write an equation, you're thinking 3 things. What's the shape? And what's b for my angle, right? So can you tell me any of those? Yeah. Amplitude's 10. So y equals negative, positive, negative. Which one? Positive, negative? I think that's the toughest toughest part of this problem is to figure, is it positive or negative, right? Is it cosecant or secant? Cosecant. And so if we look at our helper graph, like it's gonna look something like this, right? And it's the curve that goes through 0, 0. That's why we know it's coming from, did I say secant or cosecant? It's cosecant, right? Yeah, it's coming from the sine curve because this curve is going through 0, 0. Is this the positive sine curve or the negative sine curve, though? Yeah, and the way we look at it is what happens after the y-axis on the right side. So if I continue this, it's going to drop down to its minimum and then come back up and then end, right? So this is the negative sine curve, so we want a negative 10 cosecant. So something times x. And we got to now find out what b is. So then finding out what b is, what's an equation that would give us b that we can use? Okay, pi over 2. So let's see. Here's quadrant 1, so this is where pi over 2 would be. But you're over here. So I don't think we want to use that one. Yeah. 3 pi over 2? Okay, let's try that. 3 pi over 2. Well, here's pi. This is pi right here in terms of quadrants. This is where 3 pi over 2 would be in terms of quadrants. But we're on the left side. You're talking about the right side. Right? How about negative 3 pi over 2? Right? We're going back 1 pi, going back to negative 3 pi over 2. That would work. Or we could say, you know what? If I go 3 quadrants back, I'm at negative 1/2. So if I go 3 quadrants forward, I'm going to be at positive 1/2. And you could use a positive 1/2 and a positive 3 pi over 2. That's fine, right? But careful, you don't want to use a positive and a negative here. Okay. So multiply both sides by negative 2 in this case. And I'm going to get b is equal to positive 6 pi over 2, which is 3 pi. So we end up with y is negative 10 cosecant 3 pi x for our answer. Okay, so there are 3 examples that you can use, and that's the end of our notes.